The Brooklyn Bridge is one of the oldest suspension bridges in the United States that stretches 1,825 miles over the East River, connecting Manhattan and Brooklyn. On completion, it was the largest suspension bridge in the world and the first steel wire suspension bridge. Originally referred to as the New York and Brooklyn Bridge, it was informally called the Brooklyn Bridge in 1869, and formally so named by the city government in 1915. Since its opening, it has become an iconic part of the New York skyline. It was designated a National Historic Landmark in 1964. The bridge was designed by German-born John Augustus Roebling in Trenton, New Jersey. Roebling had earlier designed and constructed other suspension bridges, such as Roebling's Delaware Aqueduct in Lackawaxen, Pennsylvania, and the Waco Suspension Bridge in Waco, Texas, that served as engineering prototypes for the Brooklyn Bridge. Unfortunately, he died just after construction began from tetanus. His son Washington continued the project. Construction began January 3, 1870. The Brooklyn Bridge was completed 13 years later and was opened for use on May 24, 1883. On that first day, a total of 1,800 vehicles and 150,300 people crossed what was then the only land passage between Manhattan and Brooklyn. The bridge's main span over the East River is 1,595 feet, 6 inches. The bridge cost $15.5 million to build, and approximately 27 people died during its construction. Today, thousands of people cross the Brooklyn Bridge every day. The famous bridge is also a huge attraction for tourists, and to this day has remained toll-free. To build my model of the bridge, I used many postulates and theorems from geometry. Since my poster board wasn't long enough for my entire bridge, I decided to build it in 2 parts. I cut the poster board in half, and because of the midpoint theorem and the segment addition postulate, I was able to join them together in the end. The entire base put together is a plane on which the bridge sits. By postulate 6, which states that through any 2 points there is exactly 1 line, I could assume that many of the figures in my bridge were lines. There are many parallel as well as perpendicular lines on the model, with which we can easily apply theorems such as, in a plane, 2 lines perpendicular to the same line are parallel. Through a point outside a line, there is exactly 1 line parallel to the given line, and 2 lines parallel to a third line are parallel. There are also many rectangles in the bridge, including the roadways and the faces of all the rectangular prisms that make up the towers and the abutments. The theorem which states, if an angle of a parallelogram is a right angle, then the parallelogram is a rectangle, allows us to prove all the rectangles. The suspension cables on the ends of the bridge also create right triangles by the converse of the Pythagorean theorem. The cables in the center create congruent triangles by the SSS postulate. Overall, my model of the Brooklyn Bridge was difficult to construct, but I still enjoyed the project.